it's about mesh analysis in a circuit theory to measure the current in each mesh or in a loops in the circuit. So first of all, consider here one circuit. This is a DC voltage source. This is the polarity of this source and magnitude is Vg. Here we connect one resistance, here we connect another resistance, and this is the second loop. The value of this resistance equal to R1, R2, R3 and R4. This is a ground terminal. So look at here. In this circuit, here flows two current. In the first loop, this is called loop 1. This is the first loop, which is known as loop 1, and this is the second loop, which is also known as loop 2. In this loop, the current equal to I2. So now the direction of current is I1 equal to this direction and I2 is this direction, and here in this branch the current is I1 minus I2. Okay, because according to KCL, what do you know that if this is the incoming current I1, this is an incoming current I2, so what is the total current here? The total current is equals to summation of these two current I1 plus I2. And another example is that if this is a nodal node point, here the current equal to I1, this is the incoming current and this is the outgoing current I2. So in this branch, in the third branch, outgoing current, what is I3? The value of I3 equal to I1 minus I2. We consider here this value is I3, or another name is I1 minus I2. Okay, so this is the basic principle of KCL terminology. So now calculate what is the value of magnitude of current I1 and I2 separately. So first of all, here we consider KVL theory. So at loop 1 we apply the KVL theory. So what is the KVL? Vg, this is a voltage source Vg, is equals to, what is the potential drop? There are two potential drop which is across R1 and R2. What is the potential drop across R1? The potential drop across R1 equals to I1 into R1. And what is the potential drop here? R2, I1 minus I2, I1 minus I2 into R2. And in this loop, what is the value of, what is the KVL equation? In this loop, we here any voltage source are not connected. There is no DC voltage sources, so the magnitude of the DC voltage source equal to 0. So we write here 0. And what is the voltage drop? First voltage drop is equals to I2 into R3. Second voltage drop equals to I3 into R4. Second voltage drop equals to I3 into, sorry, not I3, I2 into R4. Okay, and the third one is I2 minus I1. Why here we consider I2 minus I1? Because this current flows in the opposite direction. This opposite direction flows. That's why we consider here I2 minus I1. Okay, in the loop analysis, when loop 1 is considered, then here the direction of this current is top to bottom. That's why you consider I1 minus I2. And in this loop 2, when we analyze the KVL, our direction is, first direction is starting from R3, R4 and then R2. So the direction is opposite side. So that's why we here consider I2 minus I1. Otherwise it may be the wrong direction, or we getting the wrong values. Okay, this should be clearly remembered. Okay, so now here we apply from the KVL equation and get the two voltage equation. This is from loop 1 and this is from loop 2. So now analysis of this equation. So I again write this equation, separate current I1 and I2 separately. So what is the value of current I1? What are the parameters associated with I1? I1, I2, R1 plus R2. And what are the parameters associated with I2? This is R2 only resistance. This is voltage 0 for loop 2. Here I1 we separate I1 and I2. What is the parameter associated with I2? The resistance R3, the resistance R4, and the resistance R2. These three parameters are associated with the current I2. Now we apply in a matrix form. This is VG0. Okay. What are the currents? There are two currents in a two loop, which is known as I1 and I2 separately. And what are the current? What are the resistance parameters? This is R1 plus R2. This is R2. This is minus R2. And we say that these three associated with these three resistance is known as R dash, because it's a very long term. So here we replace this term by R dash. Okay. So follow that. These equation is follow the KVL equation. So this is the mesh analysis from where we getting the separate current equation, separate current value from different loops, loop 1 and loop 2, because here we apply only, here we consider two loops only. So now using matrix formula we getting the separate value of I1 and I2 separately. So this is the mesh analysis from which we get the current in a different loop in any complex circuit.